At the moment, I'm still working mostly on my new Emco mini CNC lathe. As the bedways of the machine were in pretty good condition when I got the machine, I decided to install some sort of bedway protection to preserve this state as good as I possibly can. On my mini lathe, I just use a piece of impregnated fabric for protecting the bedways. This works astonishingly well during the past years and prevents the vast majority of chips, dust and dirt from falling on the machine ways, causing excessive wear. On my CNC lathe though, I wanted something more sturdy and reliable, as the machine is meant to run mostly on its own without me standing aside and watching if there is a fabric bedway protection being sucked in by the lathe chuck. Some here on YouTube use a concertino style bellow, which you can buy on different sources for protecting machine ways, but I wanted to go a different way and make a sheet metal bedway protection from stainless steel, as it is standard on big industrial machines. I started this project with buying a bunch of stainless steel sheet metal strips. The metal strips have a thickness of 0.5 mm and are 40 mm wide. This is also the width of each individual element later. I chose this number as it allows the carriage of the lathe still move as far as possible to the left, allowing to machine parts even pretty close to the lathe chuck. With wider elements, I would have lost some of the working area, which I wanted to avoid as best as I can. I started with marking the right length for the first cut. Especially for this project, I bought a small sheet metal press brake with integrated metal shear. I thought this machine should be ideal for the small parts I'm planning to make. But yeah, it wasn't. The machine is the cheap copy, I guess, of the Swiss-made Profiform 200, which is a high-quality metal shear and bending machine. I shouldn't have expected something else, but for a fraction of the price, you get a fraction of the quality. It wasn't even possible to cut the 0.5 mm sheet metal with the machine. The whole machine bent inside when I tried to cut a piece of the metal strip. A look inside the mechanism showed that there is a vast amount of play in it and everything is very sloppy made, including some interesting machining marks on the inside of the casting. All in all, it was an absolute bad purchase, and I put the machine straight back into its box for sending it back. Instead, I borrowed a bigger machine for this project, which was more capable than the previous one. So I started with cutting a piece of the metal strip to the right length, which, with the new machine, was no problem at all. I now had to mark the exact positions of the bends I'm going to make to bring the flat sheet metal into its desired shape. And this is the metal strip for the first part, with all the bending positions marked. For the bends being as perpendicular as possible, I installed a precision angle with a magnet on the press brake, which serves as a guide for bending. Now I tried to bend the metal on the exact position starting with two 90-degree bends for the legs on the outside, followed by two 100-degree bends and one bend in the middle of the part, which gives the rooftop. I had to get used to the machine at first, so a little bit of tweaking the bends with my hands was necessary. And yes, I had to make a lot of practice pieces until I got usable results. But after some twisting and tweaking, I got a somewhat promising result and the first element of the metal bedway protection. I just had to repeat the whole process now for 5 times more. But each following element has to be slightly bigger than the previous one, so that they can be put together later and fold into each other. I calculated the bends in such a way that the final parts fit with a gap between each other for a 1 mm thick felt band for sealing. And this is the second element. The parts fit quite well into each other. The gap you see will be filled with a self-adhesive felt band later, which seals the joint between the individual parts. And here a little mock-up on the machine. It's starting to look pretty cool, I think. Now let's make the element number 3. Now that you know the process, I won't show it again for the following 3 elements. And these are all the finished elements. As said, the gaps between the parts will be filled with a self-adhesive felt band. The band I bought is 1 mm thick and 10 mm wide. For my purpose, I split the band in half, making two 5 mm wide strips out of the 10 mm band. Now I started with attaching one strip of the felt band on the outside of the first sheet metal element. On the second element, I attached the felt strip along the inside of the part. Now both parts can be mounted together. Here you can see how the felt strips seal and guide the two metal parts. The gap between the two parts is relatively well closed. And again, I just had to repeat the process on the remaining parts. One felt strip on the outside and one felt strip on the inside. This way, the bedway protection slowly grew to final size. Fully extended, the bedway cover is about 19.5 centimeters long. Of course, this covers not the whole set travel of the machine, but adding more elements would have made the whole assembly too big when pushed together, so that I had to make a compromise here. But as most of the parts I'm expecting to make with this machine are more in the range of a few centimeters long, that cover should be sufficient for most of my work. If you ask me, this thing is already looking pretty cool. Now I had to think about a way of attaching the bedway cover on the left side of the machine. As I wanted the whole cover to be easily able to slide even further with the carriage to the right side as it is long, I didn't want to screw it permanently in place. Instead, I made a small piece of plastic in the rooftop shape of the cover, which has two small magnets in it. The part gets screwed onto the first sheet metal element, and the magnets stick to the headstock, holding the cover in place. The cover is now held securely in place, but when the carriage moves further to the right, the two magnets release and the cover can move with it. Now I just had to solve two problems: how to attach the cover to the carriage and how to prevent the elements from being pushed too far into each other, causing the whole thing to disassemble itself when the cover is folded together. The felt bands only act as a stop in one direction, which is the expanding direction. However, when the elements are pushed into each other, there is no stop, which prevents the whole thing from falling apart. So I decided to drill small holes for tiny M1.6 screws into the sidewalls of each element and screwed tiny cap head screws in, which act as a stop. When the screws are removed, the cover is still fully dismountable, but with the screws installed, it can't self-disassemble anymore when pushed together. To not lose some of the effective working travel because of the screw heads, I had to file some slots into the elements in which the screw heads can slide in when the cover is fully pushed together. And this is the finished sheet metal bedway cover with all the stopping screws inserted. Looks quite interesting, I think, and works pretty well so far. Now I had to find a way to attach the bedway cover to the lathe carriage. As the carriage has no straight side for mounting, I decided to make a sheet metal part which covers the whole left side of the carriage and attaches to the bedway cover. With this, I ensure that there are no gaps between the carriage and the bedway cover where chips can fall through and onto the machine ways. I first tried to make this part out of the same 0.5mm stainless steel sheet metal as the rest of the cover. But by trying to silver solder a support piece on the inside, I totally destroyed the part. The thin sheet metal warped extremely under the heat and the part was unusable afterwards. So I made a second attempt, now from 1mm stainless steel. I also changed the design of the inner piece of sheet metal for strengthening, and instead of only soldering it in, which is extremely hard without any support, I added small L profiles from brass, which connect the two parts with small M2 screws and secure them additionally for soldering. This looks way more professional than the first version. Unfortunately, I screwed this part up too during silver soldering. The part looks definitely better than the previous one, but it still warped too much for my taste and was burned black on all the surfaces. Have I said that I absolutely hate soldering? So I made all the parts a third time for one last and final try. I decided to only solder the joints where it is really necessary and let the parts which are secured by screws as they are without additional soldering. This time everything went fine and I'm pretty satisfied with the result. I now only had to drill 2 holes in the lathe carriage for mounting the part and add some tiny M1.6 screw holes in the sidewall for mounting the bedway cover. And now it's time to finally assemble the finished bedway cover with the connecting part and mount everything to the lathe. And this is the finished stainless steel sheet metal bedway cover assembly, ready to be mounted on my Emco lathe. If you ask me, the whole thing looks pretty good and seems to work quite promising. Time will tell if this thing was worth the effort and works as it is expected. I thought this project might be interesting for you, as I haven't seen this approach here on YouTube. I hope you enjoyed this episode. Let me know what you think in the comments. Thank you all for watching, and till next.